Hello, this is for summer assignment 4 where you're being asked to graph a scatter plot, determine the correlation, and also graph a residual plot. And find the equation of best fit. You might have done some of this stuff by hand before. Probably you've done something like this in physics for Dr. Thomas. But here we go. Graph. Scatter plot, and then you'll notice I have two sets of data here where we use 0 to 10, where 0 is 1990 and 10 is the year 2000, or you could use these. It does not matter which one you want to do. I think the example in the book said to do it this way. That's what I'm going to use. So X will be year, Y will be tuition, and at this point I'm just going to hit compute, and there you go. There is the scatter plot. Since the columns were year and tuition, they already had that typed in. Your axes are already labeled. Okay. One of the nice things to see though would be what is the actual line of best fit, and we want then to overlay a first degree polynomial, which is a line. X to the 1 power is a line. Okay. And if we do that, we can actually see what the line of best fit would look like. So some of the data points are above, some of the data points are below. That's pretty good, I guess. We'll need to look at the residual plot to figure that out. Now, the equation of the line can be determined many different ways. This is one way here. Put the cursor right on the line. Whoops. There you go. And you get the y values equal some constant. And in statistics, they always put the intercept first, and then they do the plus slope times x. So it's sort of like y equals b plus mx instead of mx plus b. It's just the way it's done in statistics. If you want to find the correlation, we can go to stat, summary stat, correlation, and highlight these two. Just hit compute, and you'll find the correlation between year and tuition is 0.99315872. The nice thing about correlation is that it does not matter what type of data you're using or what the labels are, what the numbers are. Correlation is a relationship, a numerical relationship between these values, and changing it from 0 to 10 or 1990 to 2000 won't change the correlation. The relationship is still the same. That's an interesting and neat fact about correlation, and that's typically going to be a question on the exam too. We'll cancel these. That's great, but there's an easier way to do all this. I don't know, why didn't you show us that first? Well, there's always more than one way to do things. If we go to stat and then regression, because we're doing a regression analysis, we'll do a simple linear. X is year, Y is tuition. Right now we'll leave all this and we'll hit compute. We get some data, and in a nice table format we get the same equation there. They tell us how many points there are. Oh, it already gives us the correlation as well in one sort of fell swoop. If you ever presented with data that doesn't have the equation here, this is where the equation data will be. You'll always have something here. It'll either be called intercept or constant, and that will be this number. And then the other number underneath, in this case it says slope, but it might be, for our example, tuition. It would say tuition. The constant is always the upper one. The slope is always the bottom one. This is always where these numbers will be. Nothing else is important until we go over it, and most of this isn't important ever. If you happen to notice, though, we have a little arrow here, and without having to do anything else, we already get the fitted line. Okay, and if we do that, we get to see the slope and intercept again. So you could copy that like we did before. Options, edit. Now all you have to do is go back to residuals versus x values down here and hit compute. We get this same data here. All these numbers are the same, but we have this, which is a residual plot. And residual plots are above and below 0. Okay, how far above and below that line, that red line, the line of best fit, is the data. Well, remember, some of the points were above, some of the points were below. Well, this is by how much they were above and below. And looking at a scatter plot is important. Okay, if you want to actually see the red line there, we could do a residual index plot, hit compute, and you'll have that red line. This sort of jumpy line thing isn't really anything we do in AP Stat, but at least you can see some of the points are above, some of the points are below. I'm pretty sure that covers it. That is assignment 4.